Starship is flown once again, and now that Flight 11 is in the history books, version 2 is gone. While it did suffer issues earlier in the year, version 2 went out with a bang. A planned bang, at the conclusion of yet another successful flight that did everything it was supposed to do. We'll of course talk in depth about everything we saw and heard on this flight and all of the extra content and information provided by SpaceX, including the amazing videos of Raptor 3 testing at McGregor and why the heck they even needed to do that crazy turn during reentry. Howdy Star fans, I'm Jack Beyer for NSF, and this is your Starbase update. Starship's 11th flight test marked the end of an era, and it did so in the best possible way, achieving all the goals planned for the mission. Let's start from the beginning and look in detail at everything that happened during this amazing flight. As you should know by now, this flight was flown by Booster 15 as the Super Heavy first stage booster and by Ship 38 as the Starship upper stage and spacecraft. Both of them had a pretty clean countdown on Monday and were loaded with the nearly 5,000 metric tons of propellant needed for launch with no issues. While this was Ship 38's first flight, it was not the first flight for Booster 15 as it had already launched and landed on Starship's 8th flight back in March. The Starship stack lifted off on October 13th at 18:23 local time or 23:23 UTC and started heading east over the Gulf. All of Booster 15's 33 Raptor 2 engines lit up for the entirety of the ascent burn, something worthy of mentioning considering that 24 of these were flight-proven engines, meaning they'd already flown once. This was further evidenced by the view from one of the launch mount cameras prior to liftoff that showed some of the Raptor engine nozzles already bent from their previous flight. As you can see, this bending must not have been an issue given the engines performed just fine during flight. Now, during ascent, we did see a bit of flapping from one of the ship's aero covers that protects part of the vehicle's side for reentry, but it wasn't really anything major because, as we'll talk about later, this didn't impact the chances of survival through reentry for the ship. Starship went through hot staging once again without issue, performing the deterministic flip that we've been used to in the last couple of flights. It is true, though, that for the boost back burn, one of the Raptor engines on Super Heavy's middle ring of 10 did not light up, but we've seen this in the past where maybe the conditions for relight of that engine were not really ideal, and so the automated systems decided to not light it up for that burn. Such is the joy of having many engines. That engine and all of the other 12 inner engines did light up though for the landing burn. Following another spicy entry through the atmosphere, Booster 15 started its landing burn, which, if you remember, was meant to test a new landing burn profile that will be used on the next version of boosters. This meant going from 13 down to 5 engines instead of going directly from 13 to 3 engines. The booster then transitioned from 5 to 3 and steadily hovered over the water without issue. It really looked a whole lot more stable than what we saw with Booster 16 on Flight 10, and it probably shows that the idea of landing with just 2 engines might be a good contingency, but really not the best one. As Elon put it on social media, this rocket had come all the way back from space and was able to hover at a precise location above the water, showing once again the well-proven design of Super Heavy up to this point. Of course, this landing burn was supposed to end up high, so that then Booster 15 would drop and plunge into the water at high speed for a self-disposable boom at the end. Trust me, you don't want large bits of this thing floating around in the water. Ask me how I know. With the new landing burn profile tested, we now don't have to guess what the pattern of 5 engines look like. It seems like of the 10 engines in the middle ring, the 2 that stay lit for that part of the burn are engines numbers 7 and 11, which are sort of on the 4 o'clock and 8 o'clock positions in the engine bay. On version 3 boosters, the engines will be clocked slightly differently, and this arrangement of 5 engines will look even more as if they were in a straight line, allowing a more symmetric landing burn than otherwise. Now, needless to say, there are a ton of different pictures and videos from our team here in the field, which we've put on social media. We've got a highlights video as well on our channel, and of course, the best of our shots from this flight are available as prints on our store at shop.nasaspaceflight.com. For example, our photographer and my good buddy Tyler Gray cooked with this amazing engine shot of Booster 15's engines as it lifted off from Starbase. I also tried my own hand at an engine shot, which is of course on the store as well, and Max got this view of the top of the booster and bottom of the ship with the hot staging ring right in the middle. This is the last time we're going to see this design of a hot staging ring ever, so that's a pretty cool shot. Of course, the star of the show was once again the ship. And yeah, star of the show, Starship. Alex wrote this script, so you can blame him for that. The ship's ascent was pretty much flawless, executing the ascent burn as expected. One of the things that we've been wanting to see for so long from Starship was a jellyfish effect. This is when it's nighttime on the ground, but the rocket is still up high in the atmosphere and being illuminated by the sun because the sun is either just about to rise or has just set over that part of the planet. So the rocket's expanding exhaust looks like a sort of giant jellyfish in the sky. Lo and behold, our very own D. Wise was stationed in the Florida Keys and was able to capture this phenomena. We've seen this many times with Falcon 9, and it's an effect that obviously tends to happen around sunrise or sunset, depending on which side of twilight one is and where the rocket is headed. Starship's 11th flight took place less than an hour before sunset at Starbase, which meant that all the way in Florida, the sun had already gone below the horizon, and that made this effect possible. Hence why D was even there. We planned this ahead of time. Thanks to this effect, we perfectly saw the staggered shutdown of the ship's Raptor vacuum and sea level engines, as well as the planned post-shutdown dump of propellant. This was also visible from other parts of Florida, and our team members, Sawyer Rosenstein and Julia Bergeron, were also able to spot this from southern Florida and from the Space Coast as well. Before launch, we turned around some of our robotic cameras at the Cape, hoping to spot it, and indeed, one of them also caught the jellyfish effect as Starship was heading over the Atlantic. I cannot wait until we start seeing Starships through these camera views, but launching right there from Florida. Fingers crossed it happens next year. Following Raptor's shutdown, Ship 38 entered its coast phase, and there were two major milestones to carry out: the deployment of 8 Starlink simulators and the relight of one of the sea-level Raptor engines using propellant from the ship's header tanks. Once again, the ship maintained attitude control and reoriented itself for Starlink deployment. During this deployment, we saw a very similar procedure to what we saw on Flight 10, but there were changes. Starship's PEZ dispenser works by stacking rows of Starlink satellites with 2 per row. The bottom row of satellites gets lowered to the deployment rail, and then the remaining stack moves up after that. Of the 2 satellites, the one in the front obviously gets released first, and then the one in the back gets released. For Flight 10, we saw that the one in the back would translate all the way back to the end of the deploy rail before being flung out the door. This time, the satellite at the back just translated to the middle and then was thrown out the door. Dan Hout from SpaceX Communications was part of the company's coverage of the flight and mentioned that since the previous flight, engineers have made a few tweaks to the deploying rail. This was so that the satellite on the back wouldn't hit the door on the way out like we saw on Flight 10. He also mentioned that the PEZ dispenser for version 3 would be more powerful and release them faster, which will mean it'll take less time for SpaceX to release all of the satellites. Dan said they plan on launching 60 Starlink V3 satellites at a time once they start, so it's gotta be a quick process. During SpaceX's coverage prior to flight, we also got to see a render of just how much bigger these V3 Starlink satellites are compared to the version 1.5 and version 2 satellites launched by Falcon 9. It's also pretty important to point out that the views of Starship were thanks to all of those version 1.5 and version 2 satellites sent into orbit by Falcon 9. Dan said on stream that thanks to Starship's 4 Starlink antennas, the ship has 120 megabits of bandwidth to send video telemetry and a lot more down to the engineers on the ground. That's faster than the internet in a lot of parts of the US, let alone the world. As the Starlink simulators kept being deployed, we noticed at least one of them from the topmost row having some strange looking hardware, including what looked like a wire. This wire also split in 2 when it was time for that top row of simulators to translate down to the deploying rail. A rather interesting thing that we're not really sure what it was, but must have been some sort of experiment or test that SpaceX was running with that top row of satellites. Please let it be that they had cameras on them. Please, please, please. Hey, at least this time we got a proper view of the deployment from the ship's flap camera, which we didn't get to see last time around. A nice cherry on top. Following the deployment of the simulators, of course, the payload bay door closed, and we had a few more minutes of coasting before the in-space Raptor relight planned for the flight. Pretty much like on Flight 10, the relight worked and SpaceX got yet another data point on Starship's ability to relight its Raptor again after launch to change its orbit, be it for an orbital inclination change or just to deorbit. With the coast phase of the flight done, then came the most stressful part of the mission, the ship's entry. For this flight, SpaceX was trying out a multitude of new things and also not doing certain things they did do on Flight 10. For example, Ship 38 did not fly with the metallic tiles that we saw on Flight 10, which ended up rusting and turning the belly of the ship orange. Ship 38 did fly with missing tiles like Ship 37, but in this case, it was a different pattern. Instead of being individual tiles, SpaceX removed them in groups of 4 at a time in certain locations of the body of the ship, such as tank welds, the nose cone, and the flaps. In these areas, instead of applying a backup ablative material like they've done on previous ships, they only had the bare steel painted black. Dan explained that this was to push the ship to the limits, that these areas are the ones that see the highest level of heating. So with no backup protection, there was bound to be some burn through and sparks flying around, which we did see during reentry. He explained this gives them an idea as to how resilient the ship is to missing tiles in the future. They even removed tiles on parts of the leading edge of the aft flaps just to see how they did. One other thing that was explained during reentry was the reason why we saw that explosion in the aft skirt back during Flight 10. Just like we thought, the culprit was the engine chill lines, which are tucked into the flap aero covers, a new design change that took place with version 2. The placement, or their design per se, was not really at fault though. Dan explained as they go up during ascent and during the coast phase, they use those vents to purge and dump propellant, and at one point during Ship 37's flight, this led to ice building up in the line. This solid propellant was then ignited either by electric discharge or by the plasma itself in the upper atmosphere, and that's what caused the explosion. So what they did to avoid that explosion this time around was just change a couple of the procedures and some of the operations, which prevented the ice buildup and subsequent explosion. It's just that easy. SpaceX also explained the reason for the tiles on the leeward side of the aft flaps, which I know a lot of you asked about in the lead up to launch. Apparently, they're testing different attachment mechanisms for the tiles that may be used in future and improved versions of the ship's heat shield. We can see, in fact, a few of the tiles may have only been held on by 2 pins instead of the usual 3 pins that we see in the current system. Some of these tiles did not survive the flight environment, so now they know which designs to not use. Apart from the tile experiments, SpaceX was running another really important experiment with this entry, simulating a catch back at Starbase's Pad 2 tower. This would see the ship doing some crazy turns and maneuvers, which we hadn't seen before, so we really had no idea what it would look like until it actually happened. But now that it's already happened, we can tell more or less what it was all about, what was happening, and why it was needed. Part of the process of coming back to Starbase means having to bleed off a lot of the speed from orbit and do a pinpoint landing at the tower, so the ship needs to be able to bleed off energy efficiently as it comes down. One way to do that is to turn left and right as you come in, so you can bleed off that energy and shorten the distance to the landing point. At around T plus 53.5 minutes, the ship initiated the first of these turns, turning to the right as it was about 67 kilometers in altitude and going about 23,000 kilometers per hour. That's nearly 19 times the speed of sound at sea level. This was followed by another turn, this time to the left at around T plus 58 minutes that was a lot more aggressive. This one took place while the ship was about 54 kilometers in altitude and while still going at 16,000 kilometers per hour. This was the final hypersonic turn that would simulate the ship coming into the South Texas area. This is also when the temperatures started to come down as the ship flew slower and slower, and some of that plasma we saw at the beginning of entry started to go away. This is, however, also the point in entry where the maximum dynamic pressure takes place as the air becomes a lot thicker than before and drag increases to its peak. You can see, in fact, in the SpaceX telemetry, the ship hits a peak G load of around 1.9 Gs at this time, which, by the way, is something pretty interesting to point out because we see on Dragon missions, the Gs during entry are closer to on the order of 4 or 5 Gs, and here we have Starship barely hitting 2. It really seems like a much smoother entry acceleration than with Dragon. Now we just need to see Starship survive re-entry as cleanly as Dragon. With the second turn complete, the ship continued to bleed off speed and went into what SpaceX called the dynamic banking maneuver. This maneuver essentially rolled the ship to its right-hand side and pitched it up so that it could fly around in what SpaceX's Dan called a half-moon loop. So at this point, you need to imagine that instead of the Indian Ocean, the ship is coming in for landing here at Starbase. It went west to east and turned left as it came to South Texas. This prevents the ship from overflying Brownsville and makes it come in over the bay in South Padre Island. The dynamic banking is to turn the ship around to the south and align it with the launch site and, of course, with the tower. This is exactly what we were able to see from the onboard camera view and telemetry as the ship turned around during this maneuver. It makes a lot of sense to do this because there's a lot going on here. You don't want to overfly populated areas, but also the ship needs to efficiently bleed off energy and do it precisely to come back to Starbase. And you also have to align the ship's orientation and trajectory with the tower's own orientation. All of this is stuff that we kind of already saw already with the space shuttle. It had similar S-turns during reentry, and at the end of its entry, it had what was called the heading alignment cone, which was a big loop around the Space Coast as it descended and aligned itself with the runway at Kennedy. The shuttle was a winged vehicle and therefore had more cross range and had to do more of these bleed-off maneuvers and turns, but it is very much a similar procedure when you compare both systems. Following the final banking maneuver, the ship entered its belly flop and then flew as if it was heading out to the launch site. Again, you sort of need to imagine that this was at Starbase instead of the Indian Ocean. In this portion of flight, the ship would be slightly north of the pad, facing almost south and dropping straight down with a slight forward velocity. Before its landing burn, the ship makes a final turn to align itself with the tower, simulating being high above and behind it ahead of the flip and landing. SpaceX even called this final turn on stream the final approach.
The ship is making its turn for final approach.
With the ship ready, the 3 sea level Raptors ignited for landing burn, and the ship successfully touched down on the waters of the Indian Ocean. SpaceX released an amazing set of clips showing this from their drones on site, which are just jaw-dropping. We can see the state of the heat shield after re-entry, and well, it's pretty toasty, as to be expected, from the many tiles that were removed on purpose. There was also still some orange, but not as much as before, likely because this time around, the missing tile areas had bare steel, and it was probably ablated, rusted, and then was spread out on the tiles. We can see, in fact, venting from the LOX tank, and from some other areas as well in the heat shield. That's most likely because of holes punched through the steel by the heat of re-entry. Thankfully, the ship engines are fed by the header tanks at the top, so what happens to the main tanks, I guess, isn't a big issue? Although you can kind of see some flames from the nose cone. I'm not sure if that's from the methane header or from something else, but wow, just either way, this is so impressive that the ship actually made it down in one piece. Now, there's also a lot to unpack from the view that we got during the SpaceX stream. First of all, unlike on Flight 10, it seems like Ship 38 was a whole lot smoother on touchdown. You can kind of see the speed gauge going all the way down to 8 kilometers per hour. Second, and most importantly, no matter how smooth the landing is, a ship is not meant to survive a tip over afterwards, so of course the ship blew up after tipping over. Starship Flight 11 went out with a bang, but an expected one, and I bet it felt amazing for the many SpaceX employees that have put so much effort into this and all prior flights. Also, that landing burn was the last time ever that a Raptor 2 was fired in flight. Remember, future ships and boosters will use Raptor 3 engines. One other thing that will be interesting to see is whether this ship catch simulation went well or not. Was it on target? I mean, yeah, the buoy is right there. You can even see it from the ship's flap camera, but was the landing as precise as SpaceX needs for a chopstick catch? I'm sure their engineers are now combing through all of the precious data that they just got to learn exactly that. And who knows, maybe they'll tell us at some point. For example, Dan also explained on the stream that Ship 38 was meant to target the exact same location in the ocean as Ship 37, and that in the case of Ship 37, it was only off by 3 meters. That would probably still be a catch though, given that 3 meters is a third of the ship's diameter and there's a significant amount of leeway. Anyway, after that dump of information from what we learned just from this crazy re-entry path, I gotta say, I cannot wait until we see it here at Starbase. I mean, I'm sure everyone is gonna just lose their minds when they see this thing twisting and turning and banking and doing aerobatics over our heads as it approaches the launch site for a catch. I mean, you thought a booster catch was crazy, just wait till a ship catch. By the way, that first catch may happen in the springtime according to Elon, but yeah. Let's say he's not the best when it comes to timelines. I mean, Elon time wasn't just coined for no reason. Also, during SpaceX's coverage, there were other things that were shown or said that either confirmed our previous reporting or at least gave us further insight into what we'll see next. For example, SpaceX confirmed that this was not the final launch of Starship from Pad 1, just the final launch in this configuration. Following this flight, SpaceX will work on upgrading the pad with a new launch mount, flame trench, set of chopsticks, you know, the works. In the meantime, they'll be using Pad 2, which is almost complete and should host its first launch very early next year. SpaceX also showed some of the progress toward the next version of Starship. As we know now, the The version 3 ship will look very similar on the outside to the current one, and it's not going to be stretched. But it will feature the docking adapters that will be used to hold ships together while they do on-orbit refilling of propellant. Internally, a lot of the avionics and propulsion systems will be upgraded for Raptor 3 and for longer endurance flights, which will be needed in order to carry out multi-orbit missions and ultimately flights to the Moon, Mars, and beyond. SpaceX confirmed that version 3 ships will be the first ones designed to do all of that. The booster will see the biggest changes, and SpaceX showed us some of their progress testing some of the test tanks we see at the Massey Outpost, like Booster 18.3 and Booster 18.1. For 18.1, they said they subjected the aft end of the booster test tank to 13,400 tons of thrust. This is almost twice the thrust of version 2 boosters and much more than the targeted 10,000 tons of thrust for Starship version 4. SpaceX also explained that the new integrated hot staging interface for version 3 boosters will carry a non-structural layer of steel on the forward dome that will protect it from the ship's engines. This layer is specifically laid over the dome in the areas where it's going to be hit by Raptor exhaust, therefore saving mass compared to having, one big thick heat shield for the entire dome like we had with the detachable hot stage ring. We also got, at last, a proper video of Raptor 3 testing at McGregor, including some crazy gimbal testing on one of the stands. They also showed a clip of our old friend Raptor Vacuum serial number 8 on the Raptor South stand being tested as well. This may not be your first Starbase update, so you might be familiar with our usual McGregor segments where we talk about Raptor 3 testing at McGregor thanks to our views from our 24/7 live stream of the site. We've already seen this RVAC quite a few times around the site, and it's also the one that was featured in Elon's presentation back in May. By the way, this is not a proper McGregor segment, but shout out to our teams there because we got a few Raptor 3s on the road once again this past week. We saw yet again Raptor 3 serial number 3 heading to the test sites, and we also spotted Raptor 3 serial number 37, the highest serial number we've seen so far. SpaceX mentioned that flight engines for next generation boosters and ships are already in production and will soon go through acceptance testing. So don't be surprised if a few Starbase update episodes from now we're like, oh my god, so many engines, they're rolling by, they're higher serial numbers than before, ah! So yeah, look out for that. Now, it's clear that this flight, while hitting all of its milestones, did still see tile loss, apart from the ones that SpaceX had already removed, of course. This could be explained by blaming those already missing tiles for exposing the surrounding ones in the same area, therefore putting them at risk of also falling off. But hey, that's probably good data if that's the case, so props to SpaceX. Future ships will definitely benefit from this data, and they'll benefit also from the massive tile production facility that SpaceX has in Florida, which they have called the Bakery. During the stream, we got a peek into this production facility, which SpaceX says has surpassed the entire tile production of the space shuttle program in just 3 years. It takes 48 hours from raw material to a finished tile, but since they make many of them at the same time, the factory is currently producing 1,000 tiles a day. However, that's just the current output. As SpaceX says, the bakery is built to produce enough tiles for 10 ships per month, or the equivalent of 7,000 tiles per day. That's like a tile every 13 seconds. It's wild. SpaceX also had a live demonstration of the so-called crunch wrap that they've been flying lately. Dan referred to it as Vulcan felt, and digging around a bit on the internet, we found this alumina fiber needled blanket from a company called Vulcan Shield, which looks a lot like the white blankets used on Starship and that Dan used during the live demo. This crunch wrap fills the gaps between tiles and prevents the heat from seeping through those gaps and down to the steel. This was something they had tested on parts of Ship 37's heat shield, and that was applied to most of Ship 38's heat shield. With Flight 11 now behind us, and this flood of information that we've gotten, what's next? Well, we need to see Booster 18 and Ship 39, the first version 3 vehicles, go through their production and testing flows. The booster and ship test tanks being built and tested right now also have to finish their own test campaigns. And then there's Pad 2, which should be getting finished in the coming months. After Flight 11, a new chapter began as well for Pad 1. About an hour and 20 minutes after launch, SpaceX fired up the water deluge one last time to empty out the tanks. The morning after, we also saw them completely venting off the carbon dioxide that was used for Starship's fire suppression system. A day after Flight 11, everything was silent at Pad 1. We've been used to seeing lifts and cranes coming back to the launch mount, scaffolding being set up again, and the work stand being installed, but now no more. Now, this isn't a goodbye to Pad 1, but more of a see you later, and we'll be following along all of these and many more developments as they take place. Flight 11 is going to be the last one for this year most likely, but we've got so much more on the horizon, and we can't wait to bring it to you all. So thanks for watching, and thanks for your support. We absolutely couldn't do it without you, and don't forget, be excellent to each other.